Good evening, everyone, and a very warm welcome to this session organized by National Astronomy Network of IAPT, that is NASNI. It is truly inspiring to have such a gathering of teachers, professors, scientists, astrophysicists, students, and parents, all united by a shared curiosity about the universe. On behalf of National Astronomy Network of IAPT, I extend my heartfelt welcome to each one of you. Today's session is a part of our ongoing effort to make astronomy accessible, engaging, and meaningful for learners and enthusiasts at all levels. Let us begin this journey of exploration and discovery today together this evening with Mr. Ram Mohan from Bengaluru. I welcome Mr. Ram Mohan Ji. He integrates contemporary scientific practice with a strong foundation in Indian astronomy, offering a distinctive perspective across both modern and traditional frameworks. We have with us one of the founder members of NASNI, Dr. Reshma Raut Kisai, Assistant Professor of School of Physical and Applied Sciences in Goa University, Pandi, Goa. I welcome Dr. Desai and will request her to formally introduce our distinguished speaker before starting talk of this evening. Dr. Desai.
Makes him a compelling voice in both contemporary and traditional astronomical discourse. So today we are delighted to have him with us on the NASNI platform to deliver a talk on an Indian introduction or an introduction to Indian astronomy. On behalf of all the NASNI members, sir, I welcome you and I request you to start today's session.
Thank you. Thank you so much. Good evening and welcome. Thank you, Dr. Hemant, and thank you, Dr. Reshma, for all that kind introduction. It's a pleasure to address this august gathering of scholars and share a bit of my knowledge in Indian astronomy or give an introduction to Indian astronomy here to this forum. So without further ado, what I would try to do now is switch off my video and I will start sharing my screen, which has got a set of slides which I'm going to talk through and which is going to be the main theme of the talk today. So with that, I'm just going to stop sharing my video and
Yes, it is visible, sir.
okay. Is it visible? I'm sharing
Yes,
the whole full screen now. Okay, thank you once again and welcome. So today's objective is to give a very short introduction of Indian astronomy. And so with that, what I'm trying to explain now is going to be from the point of view of a very scientific method of assessing and understanding what our ancient school of knowledge has been on Indian astronomy. And at any given point of time, if there are questions, you can unmute and please feel free to ask then and there. If there is an answer coming in the next set of slides, I would probably wait, or I will try to answer it as soon as you start asking the question. So there's no reason to wait till the end of the presentation. Thank you. Just a note there. Now, this is a prelude which I want to start with. Now, this is what's called as the ultimate question. This is a snippet from a book called as Our Mathematical Universe by a cosmologist called as Max Tegmark. He's a very well-known physicist and a theoretical physicist and a cosmologist. So this is a snippet picked up from his book, uh, The Mathematical Universe. What he tries to represent here is that how different cultures start viewing the very well known science of either astronomy or cosmogony, or how this whole universe came into being. Those fundamental questions, how different cultures start looking at it. And the way that it has been addressed is that there are four questions which gets addressed, and that has been tabulated in different cultures here. Is our universe infinitely old? Will our universe last forever? And are there other universes? And if something created our universe, then what was it? Now, what I have tried to do here is that marked where our interest of the talk lies today. And when I say Hinduism here, please understand that it is from the point of view of ancient culture. So here, the prevalent culture which was there in India in the ancient time has been the Hinduism, or we call as Sanatana Dharma. So that is where we have picked that up and marked it here. So there have been answers provided by each and every culture. So each and every culture gives its own opinion on these answers. So where I have marked here, and you can look at it as yes in some of the places. So like our universe infinitely old? So our culture tells yes. And will our universe last forever? It says yes for even that one. Now, here is when it starts becoming a bit surprising when this question, are there other universes? So there has been yes in our culture, whereas in most of the other cultures, it says no. Now, from the point of view of if something created our universe, then what was it? So our culture tells it came from an egg. So this is also closely correlated to the Hiranyagarbha Sutra, also which is there in our Vedic corpus. So now with that prelude, I will go to the next slide, which starts getting a bit more into what we want to dwell today on. So now this is a discourse, or this is a kind of a discussion between two sages, which have been picked up from the Mundaka Upanishad. So there is sage Angiras, who is the senior sage, and then there is sage Shaunaka, and sage Shaunaka goes to Angirasa and asks him, Sir, which is that knowledge when I know everything? So that is the question, and which is there in the first kanda, or the first section of the Mundaka Upanishad as well. So you can even go back and refer that in your leisure. Now, the way sage Angirasa explains is that there are two kinds of knowledge. One is called as the knowledge of the self, which is called as paravidya. And then there is a knowledge of the dynamic universe called as aparavidya. Now, the knowledge of the self dwells with the answers like who I am and why did I come into existence? Why do I think the way I think? Those are the questions that it starts pondering, and it starts trying to give an answer towards. And then there is a knowledge of the dynamic universe, which starts talking about the aparavidya. That is where we have the four Vedas, Rig Veda, Yajur Veda, Sam Veda, and Atharva Veda. And then we have the 6 Vedanga Shastras, which is the Shiksha, Kalpa, Vyakarana, Nirukta, Chandas, and Jyotisham. Now, these days, what has happened is that the moment you tell Jyotisham, it is always vaguely correlated with astrology. But if we start splitting the word Jyotisham and start trying to understand from the Sanskrit root point of view, Jyoti means light, Jyotisha means that it's about the study of the light itself. So that is how the word Jyotisham comes into being, not a probable right now what is being put in vogue as a corollary saying that it is astrology. So that is the introduction, that this is the kind of knowledge system that has been there from the previous ages. And I'll start getting into the next part of the explanation of the knowledge system itself, what we call today as a large compendium of knowledge system called as the Indian knowledge system, just to understand what does it all encompass. Um, are you able to see this table called as the Chaturdasha Vidyasthana?
Yes, sir. Yes, sir.
Okay. Now, if you have questions, please ask. Now, the Chaturdasha means 14 in Sanskrit. So we are talking about 14 knowledge systems or 14 knowledge areas which were being taught in the previous Gurukulas when any person who was entering the Gurukula at, say, age 8, and by the time they graduate and come out maybe at 22 years or something, these were the mandatory 14 knowledge areas that they have to learn about. And over a period of time, if somebody wants to get specialized into one or two knowledge areas, just like what we do today, and that was possible. Now, our area of interest today is Jyotisha. I will come to that. So, what are those 14 knowledge areas? There are 4 Vedas: Rig, Rig Veda, Yajur Veda, Sama Veda, and Atharva Veda. There are 6 Vedangas: Shiksha, Vyakarana, Chandas, Nirukta, Jyotisha, and Kalpa. And then we have the 4 Upangas, which is the Mimamsa, Nyaya, Purana, and Dharma Shastra. So when you add them all together, it is the 14 knowledge areas called as the Chaturdasha Vidyasthana. And each one of those shakhas or sub areas of each one of these had a lot of books or texts to be learnt about. And each one of them had to be learned in, there are certain mandatory ones, certain generalistic ones, and certain major subjects which somebody wanted to specialize in. So now from the point of view of Jyotisha here, Jyotisha always meant that you have study of astronomy coupled with mathematics. So from the point of view of Indian astronomy, mathematics is not different from astronomy as such. So always mathematics and astronomy used to go together. Just to give an instance, so anybody who was there in Gurukula used to learn about all these 14 subjects mandatorily, and somebody wanted to become a warrior, they used to learn a lot more about the Dhanur Vidya or Dhanur Veda here. So it is not only that one, they also had to learn something about the Gandharva Veda and Dhanur Veda put together. So Dhanurveda is not only about the bow and arrow, but it's the whole art of weaponry, along with strategy and everything else included. So they used to give an emphasis on total holistic method of learning to get to a kind of a major, the way that we all do today as well. So this is a large compendium of the knowledge systems which are prevalent even today, available in the Indian knowledge systems repository. So there are, and there, I think it's very difficult for people on the phone who have joined to read the secondary and the tertiary kind of things which is mentioned here, which are in a very tiny font. But I can share these slides later. you can take a look at it in leisure. So all these texts are available today. Some of them have probably been lost, or some of them have been now been rediscovered, and people are still working on many of these. But we have a large compendium of knowledge. That's what I was trying to hint. Next, I'm just going to the next slide. Now, when we start having a very large knowledge system, and I was trying to tell that astronomy and mathematics have been correlated in the Indian culture for a very long period of time, and that is what has been described even by people like Carl Sagan in his book Cosmos. The chapter 10 starts talking about that the Indian method of understanding the cosmos is one of the most sophisticated and the closest to the current way of what cosmology has been propagated. Now, that is where we start getting very big numbers. So, that is what I was trying to highlight here, where I've just tried to highlight in the uh, underline, which has been done in the blue and the yellow kind of verses there, and including some part of the verse here which tells a day and a night of Brahma is 8.64 billion years long. So when somebody starts mentioning at uh, these very large amount of numbers, though if we just start even imagining that at around maybe 4,000, 5,000 years ago, when many of the Roman numerals were very difficult to even write, and there were no decimal points or ratios being available to write in Roman numerals, we were trying to write some part of decimal systems here in the verses that we have in the Indian knowledge systems. So, what it tries to tell is that from the point of view of Indian knowledge systems and the whole Indian culture, two things were very clear. One is understanding of the nothingness. Second is the understanding of infinity. So that is where it starts telling that it can go on and on. It just tells that will billions of years from now be uttered, destroyed. So it means that it just tells that the whole cycle of creation and destruction of universes can go on for billions of years, and it can extend to infinity as well. So today infinity is very well understood concept. So if we even go back around 400, 500 years ago, or maybe even during the early medieval times, the zero was not completely understood by the West, nor was this concept of infinity understood. But so I'll just go to the next slide, um, which just talks about the origin from the book Zero, the biography of a dangerous idea by Charles C. So what Indian culture describes is that this is from the Rig Veda, the origin of zero, which this is from the Nasadiya Sukta, which talks about neither non-existence nor existence, nor the realm of space, and it just talks about Nasadiya Sukta, talks about Nasada Sinno Sadasit. So that is the whole verse, and that is where this chapter 1, the origin of zero, starts getting into the Upanishad. There is a description of infinite, so where it tells that where there is infinite, there is joy, where there is no joy in the finite. And what it tries to tell here, that there is no joy in the finite, or when there is infinite, there is joy, is that when you start imagining that you know everything, or you box yourself that, okay, I know everything, it means that you start becoming a bit more egoistic. So if you start imagining that something is there, that which is larger than largest, then you start imagining things that there is something beyond us. So that is where there is joy in knowing that there is something much larger than us. That is the concept which is explained in the Vedanga Jyotisha. So when they explored the void and the infinite and and accepted the zero. So the concept of nothingness to infinity and acceptance of zero was the fundamental things that our number systems was one of the most important things in our number systems for even the evolution of numbers, and that is what uh, which mentions here, where I have just marked in the yellow part, which it tells in the Rig Veda itself that the roots of Indian mathematics are hidden by time. So what they're trying to tell is that why did they start having those large number systems? I'll just go to the next slide. So when you have very abstract things that needs to be represented, science and mathematics are the wonderful tools that we have to represent abstract. So just by going by the definition of what is science, which is a Richard Feynman's definition. So you have some kind of a theory or concept, and then you the way you try to dispute or prove a theory is by understanding and computing the consequences. Compare your theory through an experiment, observations, or you find some references in nature. If they all agree and match with the experiment, then it starts becoming that there is a proof or an empirical evidence of things working. So this is how everywhere, I'm sure to this august audience who have been scholars in physics, I don't have to explain much on this. And that is how this whole concept of science comes in. Now, in the table below, this is a snippet that I have picked up from the Introduction to Indian Knowledge Systems book. So it just starts giving what are the different parts of Indian knowledge systems. And with part one, it talks about the Indian knowledge systems. Part two starts talking about the foundational concepts in Indian knowledge systems for science, engineering, and technology. Part three talks about the application of many of these things of science and engineering technology in the IKS. Part 4 talks about humanities and social sciences as well. So, what I've tried to mark there is where the area of interest which lies to the astronomical part and the calculation related to mathematics and measurement comes in. So there is a very clear definition and availability of text related to these things, and it is related to mathematics and astronomy and the number system and unit of measures. So that is what, in order to even imagine numbers of very large volumes, they and it was not accidental, but they wanted to measure certain entities. One of the fundamental entities that they wanted to measure was time. So that is where and the next table here starts showing this is, by the way, from a paper by Will Durant. We know Will Durant was one of the world's leading philosophers, and he starts giving reference about India's work in science by Will Durant. So I have picked that up from this paper. So where he starts explaining that Indians in the ancient times were able to manage numbers 10 raised to the power of 53, which is called as Talakshana. So this is the numbers that they were able to imagine and manage, which is mind-boggling if we have to consider around 4,000 or 5,000 years ago that they were able to even imagine such kind of numbers. 10 raised to the 53 power is not a small number by any small ways. And here it starts going from Eka, Dasha, Shata, Sahasra. These are the things that even today that we use, and it will start going towards Parardha. So Parardha is about, we are talking about a billion now. So this is how the number systems, the fundamental number systems started evolving. And then I'm getting into the history of astronomy itself from the point of view of India. Just starts getting into the introduction now. Um, uh, are you able to see this table of history of astronomy?
Yes, sir. Yes, sir.
Okay, sorry, thank you. So now this table starts giving a comparison of what was happening in India or Indian texts versus West Asia and Europe. And then there is the first is development of astronomy, and then it starts talking about certain texts. First is the Vedic texts, which Vedic Samhitas and Brahmanas, that they are nothing but the Vedas itself. And one of the earliest texts which are talking about astronomy from the point of view of having numbers and measurements is Vedanga Jyotisha, Parashara Tantra, and Vriddhagarga Samhita. So now these three texts are one of the oldest available texts in the world in astronomy, and they have been dated. The recent dates are anywhere between 1600 BCE to around 1400 BCE. That's the available dates. By the way, the Vriddhagarga Samhita, one part of the Vriddhagarga Samhita called as Mahasalilam, and this book came out only in 2024 by Professor that and a lot more of new things which are being unearthed as the days goes by. So Vedanga Jyotisha was known earlier. Parashara Tantra was came into existence, that okay, there is a book like this which talks about astronomy. That was around almost 10 years ago. And Vriddhagarga Samhita's one section of the book, or one part, or the Mahasalilam, came out only around 2 years ago. So these are the books which date back to just after the Vedic era. And then we have the other texts from the Jaina and Buddha texts, and it starts from Vasishtha Siddhanta and other Siddhantas. Even before, generally what happens is that when we start talking about Indian astronomy, few names starts coming out very easily. One is Aryabhatta, of course. Then we have Brahmagupta. Then we have Varahamira. Then we have Bhaskara and others. But it's very important to understand that before even these people came into existence, a lot of work has been done on Indian astronomy, and it has been available for a very long period of time. Now it is time that many of these works are being rediscovered. So that is where we have the ancient Vasishtha Siddhanta and other Siddhantas coming in. And then just before the advent of the common era, we have something called as Yavana Jataka. So Yavana here means Greek in Sanskrit. Jataka relates to the Hora Shastras, or the astrology part. So that was available to us because there was a lot of cross trade and information exchange which happened during Chandragupta Maurya's time between the Greeks and Indians. And one of the texts which is highlighted here is Yavana Jataka. So I'm just explaining that there is, just before we know certain people whom we very well recognize, there has been a lot of other people who have worked on Indian astronomy. And when we start comparing that with what was existing in West Asia, it is incomparable, because these texts which I mentioned, there is nobody else in the world at that given point of time they had any information about a systematic set of observations that they did. So there have been talking about Egyptians did and Babylonians did, and yes, they have been doing, but they have been doing a bit more later than these texts which we are mentioning about. So now in every slide that I am trying to show, I have always given where the source is from. So you can go back and refer to the source, and this has all been either that I have collected from my notes, which I have attended as classes, or the introduction lectures from many of the people like MD Srinivas, or Professor K. Ram Subramaniam from IIT, and others, or some of the works that I have been trying to do along with my other friends who have been doing active research in Indian astronomy, whom I am involved with. So I've just moved to the next table. This is once again a cross reference once again to the previous table. This is a chronological table which is available within the Government of India's history of Indian calendar, or history of calendar report by CISR. This is a publicly available text. You can download this from internet. It gives more or less the same kind of a chronological order of what was happening in Indian mathematics and astronomy when compared with other civilizations of the world which were existing at that period of time. And now coming to a bit more into the measuramental parts. So I'm going into the chronological data, which is available in another book called as Katyayana's Sulba Sutra, this is by S.D. Khadilkar of Vaidika Samshodhana Mandala of Pune, where he also gives the name of each one of the previous astronomers or mathematicians like Baudhayana, Apastamba, Aryabhata, and Varahamihira, and the name of their work and the probabilistic dates at what point of time that these texts were created. So we can talk about the period of Vedic Samhitas according to this text is around 4000 BCE, and then we are talking about Panini's uh, text on grammar to be 600 BCE. So we are then Shatapatha Brahmana being 3000 BCE and so on. So we're just talking about these are, by the way, Baudhayana, Apastamba, all these Sulba Sutra texts are very geometrical in nature. They offer an insight into how do we construct fire altars. How it means that it is very geometrical, understanding the areas of a circle, areas of a square, areas of a triangle. It goes there, and how to equalize and measure all of them and how to construct them. So that is what the Sulba Sutra talks about. I'll give a very brief introduction of that as well in the next few slides. So, with all this information about a bit of history of what Indian astronomy has been ongoing for a very long period of time, now the time has come to understand why were we using astronomy as a tool, and what were we using that for. So the fundamental usage of Indian astronomy, everywhere the overarching theme runs of three things that they wanted to always do. And first of that is called as the Dik Desha Kala Nirnayaha, which means that Dik is direction, place, and time. So the whole subject area of astronomy and mathematics was used to determine these three entities: direction, place, and time. That's the overarching theme that runs through, and that is why we had the panchangas or the calendars, and that is the whole reason of understanding how long periods of time are. And in order to understand place, we had to get into measurement of areas, and then in order to understand how to determine directions, we had to understand first four directions, and then we had to subdivide that into understand the eight directions, and then considering up and down all the 10 directions across. So they started going from 2D to applying things in 3D as well in the later parts. So just by giving some introduction about what is present in one of the oldest texts here, Vedanga Jyotisha. So Vedanga Jyotisha is a text which was uh, put together by Lagada Mahamuni. So where what he has done is that in the Rig Veda there is Archa Jyotisha, which has got 36 verses, and in Yajurveda there is Yajush Jyotisha, which has got 43 verses, and these two put together is been formed as a text called as Vedanga Jyotisha. So what it tries to give as a summary is that the movement of the moon along the ecliptic, that is the first time there they describe the 27 nakshatras, that is the Ashwini, Bharani, Kritika, Rohini, Mrigashira, so on, and they give the 27 nakshatras and how the moon is moving across these lunar mansions. And the fundamental nature of this calendar was to understand that the month movement of the month or the happening of a month is measured by the moon, and the happening of an year is measured by the sun. So the ayana, that is the Uttarayana and Dakshinayana, the movement of the sun, and the masa or the month is measured by the moon. When these two are put together, it starts explaining the passing of the year itself. So that is where Vedanga Jyotisha starts explaining how when moon moves across these 27 nakshatra divisions, a passage of a year happens, and there have been very clear explanation uh, of 365 point whatever is the current year in terms of days has been explained in the Vedanga Jyotisha. I've not been able to put the verse here. So what it means is that it also gives, in this particular book, it starts giving the explanation of what Jyotisha means. It tells Jyotisha is a subject or a shastra or a siddhanta which teaches us how to determine the time, place, and direction, Digdesha Kala, by observing the motion of celestial bodies. So here is where the fundamental nature of observation starts coming in, which is very important as a science of astronomy. They start observing celestial objects, how celestial objects are moving across in the sky, and from there they start determining the passage of time itself. So that is where they say that, which I was mentioning, there are 6 Vedangas. So among that, Jyotisha has been given a very, very important uh, 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 level of knowledge. It tells that Jyotisha is the eye of the Vedas. So it's one of the top of the 6 Anakshar of Vedas. So this particular verse in Sanskrit explains that Yatha Shikha Mayuranam Naganam Maniyo Yatha Tadvad Vedanga Shastranam Jyotisham Mu Vardhini Sthitham. Jyotisham Mu Vardhini Sthitham means that among the others, it's just like the comb on the head of a peacock or a jewel on the head of a snake. The scientific composition of Jyotisha occupies the position at the top of the 6 of all Anakshar of Vedas. So it means that if you have to really understand the Vedas, this is a very important Jyotisha. It becomes very important as this gives you the vision to understand the other Vedic knowledge systems itself. So that is how important was astronomy even in our culture for a very long period of time now. Now, I'll just start giving some introduction about the units of measures, how they were derived units of measures in the ancient times. So, angula, which is approximately equal to an inch, or it is one phalange of the finger, that length is equal to 6 barley corns, which are placed in their width wise side by side. So when you place 6 barley corns, by the way, we need to understand that barley, they did not take wheat or rice or any other cereal. By the way, they have taken barley. That's because barley across has got a standard measurement, whereas in case of rice or wheat, there are different kinds of rice or wheat which can be grown, and based on that the size of the rice is also, grain of rice is also different. But barley as such is not varying. So it means that this shows the power of observation that they had, not only on only the celestial bodies, but on nature itself, and on grains and basic things which are available to them. Or the other measure was the sesame seeds or tilaha. 34 of them you keep next to each other, that also equals to 1 angula. So now when you have 1 angula, then you have 120 angulas as one purusha. Purusha is nothing but an approximate height of a man or a human being, that is purusha. So that is how they were able to translate a angula into a larger portions of measurement, and they were able to go into uh, a larger area of measurement itself. So that is the fundamental observation that they had in terms of understanding the area here, and then coming to the measurement of time, which I was just telling that in the in the Vedanga Jyotisha itself, it tells that 366 days form a solar year. In the year, there are 6 rutus. Rutus here is seasons, and 2 ayanas, which is Uttarayana and Dakshinayana. And in the year, there are 12 solar months. So 5 years make a yuga. So probably in one of the next sessions where we start getting into a lot more depth of the Indian mathematics, I can start explaining how the yuga was derived and what really the idea there is. In a short way to explain, when we have the months measured by the moon and the passing of a year measured by the sun, they need to be balanced for the leap year kind of a thing. And they were started with the 3.5 years first, and then standardized it to a 5 year measurement of balancing of both the calendars, or using a intercalary month introduction into the Panchanga system, which goes on even today, which is called as the Adhika Masa kind of effect. So this is how they were able to standardize the measurements. And by the way, to even understand how to measure time, they took a very simple tool. So, like Gurvakshara and Matra. So, Gurvakshara is Matra here is A. Gurvakshara is the longer syllable A. So, that is the Gurvakshara. So, 5 such Gurvaksharas or longer syllables once uttered starts becoming a Kastha. So, that way they were able to start determining the understanding and measurement of time, and this got extended into nadikas, which is equal to one muhurta is 48 minutes. So on 30 muhurtas becomes one civil day, and so on and so on. So this is where they started giving definitions of understanding time and understanding the area, which is in terms of angula. These are fundamental units of measure, like what we have the SI units today, and this is what was used previously in India. So I'm just giving a very short introduction of Sulba Sutra, which starts about when we start having a lot of sacrificial altars, which we also perform the yagnas even today, how to draw and build those sacrificial altars and why they need to be in a certain geometric form, and all that has been explained. So in order to do that, you need to follow or practice a certain set of geometrical theorems in order to build them. So those method and procedures of building those sacrificial altars are explained in Sulba Sutra. Sulbha here means thread. Sutras are nothing but a set of procedures which give you step-by-step explanation of how do you start building these altars. I'll just go to the next slide. So sacrificial altars are of this is the plan of the sacrificial ground, and these are the sacrificial altars, which we also have a square or a semicircle or a circle. And in order to draw all these, and we need to make sure that when you draw any of these semicircle or circle or a square, the areas of each one of these needs to be equal to the other. So it means that in order to find out all that, they have described in Sulba Sutras how to draw them so that you can make sure that all the areas of each one of these can be equal. So this is a method of which they describe there are various types of altars in various form. Like this is in a Sena city is a form of a falcon. Then we have the kurma, and then we have this form which is in a kind of a roundel, and here we have another square, and each of these forms have different kind of bricks being laid out. By the way, this is 2D, and if you start looking at it in 3D, the bricks need to be of 5 layers of bricks, and there is a reason why it is 5 layers. All that has been described, and they need to be in a certain form. And if you can see, all of these are made out of geometrical shapes, which is either a part of a square or a rectangle or a triangle. So in order to derive all this, you need to understand fundamental theorems of geometry and start building them accordingly. So all the explanations of how to build them have been given in this Sulba Sutras. So hope you're able to see this slide. This is a picture which starts giving you how in modern times, and these are the pictures that I have built these tools myself. Uh, the Shanku Yantra and the Sulbha. Here is the thread with these three nails in form of the wooden nails, and each one of them have a certain measurement to follow. And with this, you will be able to determine. One is the seasons. Second is you can determine the directions. And so in order to derive that, there needs to be instruments that needs to be built in a specific ratio. So, and these measuring cord and the extended cords are supposed to be in a specific ratio, and then you can start deriving the properties of the right angle triangle and everything. So probably this requires another set of discussion on how they were deriving all this, but it is possible. So this is a set of pictures of working instruments that I have built myself, and I have been using these instruments in my observatory to determine directions. And just going to the next slide, which shows a set of pictures about how you can start deriving the directions using those tools there. Just by looking at the sun's shadow falling, you can start determining the celestial directions. So there is a procedure for doing that. Probably we can discuss about that some other time. This requires a dedicated kind of an introduction to do that. So but yeah, this is what I have been doing in my uh, rooftop to derive the directions, celestial directions, using a method which has been described by around in 800 BCE by Baudhayana's Sulba Sutra method. So I have used this method to derive east, west, north, and south. It's very important for us who have been doing astrophotography. Most of our mounts which we use needs to align to celestial north. But Bangalore is very low in, first of all, in its latitude. Most of the time, we won't be able to see the North Star because it gets blocked by either the buildings or the trees or something of that sort. But we should be able to derive the celestial north for most of our astronomy, modern astronomy equipment to work. So I have used this method to derive the celestial directions, and this has given me a very perfect way of aligning to celestial north and do all my observations and take pictures of the skies. So this is just an introduction about how you can go and do about it. And yeah, even today, most of those methods which have been explained millennia ago can be reused. It's just about that. So sorry. Next is we just by observing the shadow of the sun, we can also find out the which month we are in, and there is a method to do that. And this is the Shankhu Yantra present at Jantar Mantar in Ujjain, and there is a method to find out which month we are in just by looking at where the sun's shadow is following, either in during the morning or in the afternoon, and you can find out which month we are in. So there is a method to even do that. I'm just giving a little bit of an introduction here, and there have been procedures explained how to determine the month. And determination of time is also possible by using the Samrat Yantra, which is there even in Jantar Mantar and other places, even in Delhi and even in Ujjain. and in Varanasi and in Jaipur, just by observing where the shadow of the sun falls. By the way, this slide needs to be equal to the latitude of the place where you are, and just by looking at the sun shadow falling on this arc here, you can determine what time it is. So that's about using very simple tools and shadows. And but the construction of all this requires complex geometry and understanding of mathematics. But once done, it's a very useful set of equipment to understand and measure time very effectively. So using a gnomon, gnomon is, or shanku is also called as gnomon, and that is. And this sorry, if I am too fast, please stop me. Or I think I can finish it in 5 more minutes. Is that okay?
Yes, sir. Yes, sir. You take your time. Yes, sir.
Okay. So this slide just gives an introduction of how the observation of movement of the moon across the 27 nakshatras shows. So this is a very modern um, simulation. If you have a tool like Stellarium, you can simulate it as well and find out how the moon is moving across these 27 nakshatras or asterisms, that and find out uh, the passage of an year. So this is called as the lunar mansions or moon's abode. I'm sure many of us already know about it. So this is possible even today. One thing which I just want to show here is that at some points it starts giving you a very smooth set of dots, and other points the moon starts moving in a very wavy fashion where the dots are not that smooth. So there is a reason for all this. Probably these observations have pointed out how the moon moves and how we can measure the variations of the seasons and the variations of the months. So this was determined even during the olden days, and they were updating this based on new observations in their calendars or the panchangas. Yeah, this is just a pictorial representation of those 27 asterisms that we have, or the nakshatras, and how the moon moves. And this picture is more from the point of view of astrology rather than astronomy, but the picture was good just to show the names of the names of all these 27 asterisms were very clear, like Ashwini, Bharani, Kritika, Rohini. Even today we can see these asterisms in the sky and find out when the moon is on these asterisms, and we can determine what month we are in, and how the moon is going to transit to the next asterism, and the uh, change of the month and the seasons. So this gives a method of how they were able to understand the movement of the moon and also record the movement of the sun across these asterisms and determine the passage of an year and the passage of a month. This just gives an idea of the names of the Indian asterisms with an translation in English. So, and what is the Western associated stars? So, like the Ashwini starts in Aries, and then we have Kritika, which is the Pleiades, Rohini being the Aldebaran, and so on. So, this gives a cross reference of what is the Indian nakshatra name versus the Western associated stars, or the IAU definition of the stars that we follow today. So this is just a ready reckoner, and this is once again the same Indian constellations as compared to the uh, current IAU constellations like Capricorn. Aquarius is where you can find the Shatabhisha, and Pisces is where you can find the Revati, and Aries is where you can find the Ashwini, so on and so on. So it just gives a redirectioner to understand and cross reference between the current IAU names versus the Indian names. So probably what I would do is that this is a very curious concept to understand. By the way, this picture is a set of three fire altars which I had explained, and in the center is a fire altar called as Darsa and Purnamasa Vedhi. So Darsha meaning uh, Amavasya or a new moon day, Purnamasa is Purnima or full moon day, and this altar has a peculiar shape than the other ones. These are straightforward geometrical shapes, be it a square or a semicircle or a circle. But the one in the center is a peculiar shape, and the reason that this has been in this shape is that it shows. Now, the way this shape is derived is very simple. You 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 have an imaginary horizon, which is a horizon on in the sky, and every day you start observing where the moon is rising. You draw somewhere called as a zero, and then you can have a moon rising either on the left on the right side of it, and you start having this observations, and on the ground you start keeping pebbles whether the moon is rising to the left or the right. So when you observe the pattern in which moon rise happens every day over a period of 18 years, you find a pattern like this hourglass thing. By the way, the 18 years is also called as a Saros cycle, which is also linked to the eclipse cycle itself. So this is an altar which kind of honors the moon's 18-year cycle or the eclipse cycle, and the same has been recreated in the form of an altar here. So all I was trying to just tell is that how observations, what is happening in the sky, were kind of transformed on the ground as well, just as a method of observation and thanksgiving to the celestial objects that were so helpful for us to either give us time, and we were able to understand the passage of time just by observing them. So that is what this is representing. But there's a lot of mathematics in that, so I will not probably go through that today. So this is just a representation of how binary stars were seen, and this is a video of when you observe these two binary stars, which is the Mizar and Alcor, or Vasishtha and Arundhati, through a telescope. They appear like this, and when you actually observe it through a much resolution, better resolution, you can very distinctly see that there is a bigger star and there is a smaller star. This is the Vasishtha and this is the Arundhati. By the way, Vasishtha itself is a 4 star and Arundhati is a 2 star. That means it's both are binary stars. So they had a very unique way, I don't know how, of understanding that. First they understood that there are stars which go around other stars, and the unique method of Vasishtha and Arundhati going across each other, and unique method of rotation was also understood by our ancients. So just telling that how observations over a period of time was not only limited to sun and moon, but they started observing the stars and everything. So with this, what I am probably I will end, and these are the set of books or references if somebody wants to explore a lot more further. I've just given reference of the books where you can go and start getting into the introduction part of the Indian astronomy. These are many books which are available, and it's just given some snippets of some of those books where you can go back and refer. And with that, I end my introduction talk today. Thank you so much once again for all your patience and providing me this opportunity to address such august gathering.
Thank you so much, Ram sir, for such a detailed and very nice talk about the Indian astronomy. And you are linking the Indian astronomy with the modern observations with your own way. Now we invite questions from the members present today.
Sir, it
Is
was
there any
fantastic.
question?
Sir.
Yes. Yes, sir.
Can I explain the shadow which helps to understand the month once again, please?
How do you understand the month by looking at the shadow, you mean?
Yeah, yes, yes, sir.
Okay, maybe I can explain this, but it will be always better to perform it through an experiment. Maybe in one of the next talks, if I get time, I can explain it through a tool and actually how it can be measured through an experiment as well. It can be done very easily, but we need to go into a little bit more details before it can be explained in a bit more details are needed. So that is where today I think I will not be able to get into that depth, but it is possible. That much I can really answer.
Okay, sir, no problem. Sir, are you from Bangalore?
Yeah, very much from Bangalore.
Then you know Kannada. I'm also from Karnataka, Balkot, sir.
Okay. Yes, yes.
Okay, sir. I will meet you, sir, definitely.
Oh, sure, sure.
Thank you, sir. ಧನ್ಯವಾದಗಳು.
Namaste.
Yes, any other question, please? Yes, sir. Aluwali, sir, please go on.
Yeah. I was just interested in asking a very simple question. Thank you very much, Professor Ram, for giving us this wonderful talk. And I think the categorization which today you shared, that is quite interesting. Normally people don't know that such comparisons are available with the Western astronomy. But there is one thing, wherever the human being has been, we have found the same patterns. That is the very interesting aspect of everything, isn't it?
Yeah, I think curiosity has been a very inherent nature of human beings across the globe, and every civilization, when they started looking at the skies and looking at the stars, the wonder has been the same for everybody, and they were able to give names to the asterisms or some references to stars in their own way in every civilization. But it is very true that the wonder and the curiosity is the same.
Yes, that is one thing. Secondly, there is, when we are talking about Jyotish here, there is something called the Jyotish in your sense, which you presented in this talk. It was not at all related with the meaning which normally people relate with Jyotish as astrology, for example. I don't think when you look at the scientific side of our studies in India or across our land, they were which is very interesting, much ahead of the Western science itself. But then, what was that really which made us just go into a kind of a hibernation, and Western world really took over and started moving ahead? We sometimes, keep on hearing about also that, all those things which were discovered by, say, Newton, or say by uh, Kepler, or by Tycho Brahe, they were already there in our scriptures. Do you agree with this kind of a statement, or it is too much of a stretching of imagination?
I think sincerely, as a set of people here with scientific mind, we need to go with objectivity rather than believing in bombastic nature of uh, telling that okay, everything is present in our scriptures. Now, wherever there are credible evidences which can be provided that it has been there and they have worked on it with empirical proof, and if that is presented, and it is well and good that we start uh, reclaiming some part of the misunderstood conception that everything came from the West. Yes, that can be done, like what the Fibonacci series has now been named as the Hemachandra series. So
Mhm.
so it means that so there is some part of it which has got credible evidences which we can go back and claim that this was present, and there is a method in which calculus was also discovered in India by the Madhavas or the Kerala school, which is 250 years much before Newton. But claiming and telling that whatever Newton or Tycho Brahe or others did was all always present, I don't think that's a good way of doing. That's my personal opinion. uh,
Good.
so we need to go
Because
with
there is
objectivity.
one thing which I would again like to mention, that when we are trying to see, when we are talking about Indian knowledge system, I think it should be taught as a separate subject, and we should not really start making, what you call sampling of this at various places, uh, where it loses its what you call focus itself.
Yeah.
What is happening today is that we are trying to bring in Indian knowledge system, in the name of Indian knowledge system, a kind of a sprinkling of things, but we do not really talk those things fully the way you talked. I mean, that is what is a very crucial point which we really need to keep in mind, because we are physics students, and in physics, for example, if I start throwing things in a fashion where it loses its meaning itself, I think that we should always try to avoid. When we talk about, say, for example, the Hemchandra numbers, now Fibonacci numbers, which used to be called, if you bring that in mathematics, I think it is just wonderful. There is no dispute about it. But when those stretches of imagination start creeping in the name of Indian knowledge system, I think that is a danger which we will have to really be very careful about.
Yes, I
What do you
agree.
think about my remarks? I don't know whether I am saying it uh, out of my training as a physics wala, but I believe that this is something which must be done. I would
Yes,
very much like to study Indian knowledge system, but as a separate subject itself. Part of it historical, part of it scientific, part of it anecdotal, part of it, just hearsay. I think that distinction we need to really make.
yes, I completely agree with you. That is where I think one is going through the text. Next is having to develop our own tools to also check whether, from the point of view of experiments, these can be reworked and are they relevant to today's world as well. So, or go back and understand that, okay, it was working earlier this way, and even today it works the same way. That means you start getting credible proofs of things being worked, and you have tools which can explain the same science being explored in the previous, in the ancient ways, and reoccurring it today in the same way when you apply the same procedures. It means it works. So it's very straightforward ways of objectivity being brought in. So I think that needs to be looked into, and that is where audience like this can help getting into that kind of objectivity rather than just false claims.
Another thing which I would really like, because we in IAPT are very objective people, and we would like that. Can we really do some kind of projects where we try to look at all these kinds of things uh, by conducting experiments which are of good interest to us. For example, today you were talking in the beginning of some measuring tools like that shanku, which you really shared, which is a very simple device. I mean, it's really like a small pendulum, but which is made of, say, wood, and you are trying to really look at the shadows of that itself to see various aspects. I mean, these are the things, if we can really create, talk of these as the kinds of innovations which Indian astronomy brought into when they were trying to study the astronomical objects being seen by them, what was going on. And particularly, our students do not find much interest in what we call as jantar mantar. Now, jantar mantar actually means some kind of a abracadabra kind of a feeling it gives, whereas it is highly scientific. I think we need to really not talk about this as jantar mantar, but it should be called as astronomical yantras.
Yes.
When we even try to tell people about this in Indian knowledge system. Maybe if you can give us a talk on, say, some such, for example, in Delhi there is one, in Jaipur there is another, and highly scientific things are there which people have observed. They have made records also. I think the observational aspect of our astronomy is very, very strong. I don't know whether I'm right or not, but I feel it is like that.
Yes, sir. It is very strong. There is a very detailed record of observations that have been recorded, and they are available. And that is how they were able to uh, go from the basic observations to creating very complex mathematical calculations. Without observations, without data, without analysis, it was not possible. So maybe in one of the next episodes, we can definitely do that.
Because at the moment, there was one thing which was coming to my mind. Kepler got Tycho Brahe's observation tables actually.
Yes, yes,
We also have our observation tables. Can we
yes.
really compare those and try to get that we were also, on the verge of those kinds of discoveries which Kepler could make? Because we are always saying that we are moving around the sun, we had no notion which was different from this. So we were ahead in that sense also. So can we really, is there some kind of a study which has been done to bring in, uh, say, comparison between the observations which Tycho Brahe did and what we were doing?
Now, if you tell direct, that is where I think we need to just shift a bit our understanding, because we have been taught in a Western style of understanding problems and solutions to the problems.
Mm-hmm.
The Indian way of trying to understand the problem and solution to the problem was different, which I was explaining, that their whole focus was on finding dik, desha, and kala, that is direction, place, and time. And they wanted to very accurately measure time, or accurately measure the direction, or to assess where they are on the earth, kind of thing. That is the desha coming. So when we start comparing that with Kepler or somebody, we are trying to compare two different kind of approaches, or two different problems altogether. So we might
But
not
uh,
get.
but but don't you think that they may lead to the same solutions, same kind of patterns, and that is what is the most beautiful aspect which can be seen via such studies. I
Yes,
don't know.
of
I'm just
course.
trying to imagine the things.
Yeah, maybe in one of the other talks, I will try to explain how the tithi. We all know about this word, but how was it actually derived, and what is the scientific basis of that one? And this talks about the separation angle between sun and the moon to be 12 degrees, and so on. So it means that how they were able to measure that. So it means that it's a set of observations that needs to be done, like what Kepler also did, or Tycho Brahe
Mhm.
also did. So you need to have
Mhm.
those observations, that they might have been doing it here. As I explained, in one of those 18-year cycle of the moon, you can see how many dots were there to even create those hour clock,
Yeah.
our kind of, that's the, it's a pure observational thing. So it means that
Mm.
data was analyzed not for one day, it was for 18 years. So they had this tradition. So what really happened later, it's a historical thing, but we can understand that the culture was prevalent at that point of time.
Mhm. Thank you very much, Professor Ram Mohan. I really enjoyed your talk. It was
Sir,
just wonderful. Thank you very
thank you
much
so
for
much.
coming
I'm not a
for this.
professor. I'm just an engineer.
Sir,
There is
Professor,
one more
actually,
question from.
our notion means acharya. And if you
Yeah.
have made these studies, you are the acharya.
Thank you.
And I, on behalf of IPT, say a big thank you to come to our platform and share these things with us. Thank you very much.
Thank you,
And there
sir.
are other
Yeah.
questions also, please.
Sir,
There is
sir, sir,
another
sir.
question, sir. from Jalmi Gautam. One more question. Yes,
Sure.
Jalmi. Jalmi, ask your question.
Hello, sir. Hello, sir.
Yes.
Am I audible?
Yes,
Yes,
you are.
yes.
Good evening.
Okay. Yeah. Good evening, sir. This is Gautam Jalme from Goa. Thank you for that interesting talk, sir.
Thank you.
Before actually joining this talk, I was having three questions in my mind, and you kind of touched all three of them. So actually, I will ask only one question, which is troubling me more, just and for the curiosity point of view. Um, uh, Actually, as we know, there are many Indian festivals which has the names related to the either to the moon phases or maybe stars and nakshatras. So my question is there actually in Goa we have one folk festival which we celebrate during the Diwali time, which is called as Katiyo, which has direct references to the star cluster Pleiades. So my question is there any other Indian festivals which have direct references to the stars or clusters? Meaning without watching them, they can't complete their rituals.
There may be many of them, either folk or the mainstream festivals. So the reason is very simple. All our Indian calendrical systems have been based on what is happening on that sky on that particular day. So when we talk about even Ganesh Chaturthi, it is the fourth day of the moon, and that is when we
Correct.
celebrate. So I'm just leaving. So it might not be looking at Kritika on that day, but we are looking at if the moon is on the fourth day of the moon, and to observe even this festival. So even say for example Krishna Janmashtami, we are at the eighth day of the moon. So either the waxing phase or the waning phase, and it's very direct correlation between what is going on in the sky. So it means that it's a very simple method and more accurate method of observing anything, and that being celebrated on that event or a day. So that has been very clear in all our festivals or events. Now when you start talking about certain variations, like what happens in Goa versus what happens in Karnataka, there is a change in the latitude of Karnataka versus Goa. So all our Panchanga systems, where when we follow a certain set of Panchanga, it is tied to a latitude. So here in down south, where I belong to, in Karnataka, in Bangalore near Mysore, we all follow something called as Vontikopal Panchanga. So it means that it is more localized to this latitude. So maybe you are following a Panchanga once again, which is more localized to your latitude there in Goa. So the determination of all these are based on that, and the algorithm remains the same. It is only because of a latitude, which is one of the variables within the algorithm, there is a change in the festival or the event.
Okay. But my question was a little bit different. Maybe I am not able to explain
So
it
you are asking
properly.
whether any other star clusters are there. Yes, there are. So when we start talking about clusters, we need to understand something about what is meant by a nakshatra versus what is meant by an asterism. Okay.
Mm.
So Kritika, when we say it's in Indian way, it is a collection of 6 stars or 7 stars. Okay, depends upon how we look at it. We still call it as one nakshatra. So it becomes an asterism. Okay. So it means that though there is a difference between nakshatra and tara. Tara means a single star.
Single
Nakshatra might
star.
be okay. Group of stars which can form an asterism roughly can become a nakshatra. Okay, so here is where we need to understand a little more of basics to even get to explain your question in a lot more detail. That is what I was trying to hint. Okay, so
Okay.
there are many such instances which comes, but in order to give that answer very effectively, you need to understand how it is observed or seen in the form in the sky. Okay, that's how it is. Like say for example, Punarvasu is called as one nakshatra. It is made up of two taras, Diti and Aditi. Okay, two taras. Punarvasu, as such, is also related as a name or nakshatra of Rama. Rama was born when moon was in Punarvasu. That's how you determine it. Okay. So I'm just telling so that, before you go there, we need to go a little more deeper to understand the concept. Then it becomes easier.
Okay. Okay. Thank you very much, sir.
Yeah.
Sir.
Hello.
Yeah, madam.
Can you? Yeah,
Yes,
carry
yes,
on.
madam. Go
No,
ahead,
you carry
please.
on. You
Yes.
ask your question.
Okay.
Okay, fine. So
Initially,
I would
sir
say
was telling about Veda like that. So in Shatapatha Brahmana, one sloka comes like this. It is a hint about aliens. Prithvi apaha tapamsi antariksha chandramaha surya anye graha cha vasavaha uchyante vasayo hi bhavanti praninam api cha jadanam. Means not only the Prithvi but also in the universe there are so many Surya, Chandra, and other living and non-living things are existing. So this is the quote from Shatapatha Brahmana Grantha. So actually he explained beautifully, but this content should be in high school or college level. We are lacking and we're losing the our Sanatana knowledge. But in Vedas, everything is given. But the only problem is that the Panditas, the so-called Panditas, are not preparing to interpret it as the meaning which is given in Vedas. So that is the lack of knowledge in India. We are all following Western science. Okay, thank you.
Thank you.
Yeah.
yeah.
Sir, it was. Yes, madam. Please go
I'll
ahead.
just come in now. So, sir, I would say that this is really at another very, very highly informative like session that we had today, and I'm really impressed by the way, by the, I must say, your definition of Jyotish Shastra, which I never heard about before. I would like to know whether I can get some more information about this because you touch the, I mean, you said the word Jyoti, you connected it to it. So I would like to have to read more on this. Could you please tell like in which reference I can get this?
Yeah, sure. So there is so it is called as Introduction to Indian Astronomy, and I will just probably share that slide. And
Okay.
there is a book or a two-volume series by Shankar Balakrishna Dikshit. So okay, so this can be downloaded. This is very much freely available for everybody. This is if you know that it's a Government of India backed text. Okay, so Shankar Balakrishna Dikshit and Balagangadhar Tilak were contemporaries and good friends. They have worked a lot on understanding our own ancient knowledge systems and doing that in a very and putting it in a very scientific form. So if you can get a hold of that copy and download it and go through that in the first volume itself, you will get a lot of information about it.
Yeah, sure. I'll try to get that book by Shankar Balakrishna. I must say that this was really a beautiful session, and actually our group is very large. But maybe due to some internet issue, which even I had today, many people have not been able to attend today. But we would like to have, I think, more sessions of yours. Am I right, sir, Hemant sir?
Yes, we will invite sir again. Yeah.
Yes, and also maybe when we have a offline session of NASNI, we would like to have him so that we could see some of those experiments which he showed us through which he showed through pictorially. So that would really help. Yeah, so that would be nice. One of the session that we could have is of this kind. Yeah. Thank you so much, sir.
In fact, ma'am, I was the room partner of Mr. Ram at Ujjain conference, and I learned so much from Ram, and I have seen these instruments in his bag all the time, and
in bag.
we had
Amazing.
very long discussions by 1 or 2 in the night also, and then I am very much impressed with his explanation of this astrology with the scientific temperament. Like he has explained this Vedanga Jyotisha and 6 Vedang by distance, time, and direction method, which I have never heard from anybody. And he has given. We have learned in our physics only multiples and submultiples in 10th or 11th class. But I never knew that in our astronomy, in Indian astronomy, we have very small measurements like angula, purusha, like that. And so that was amazing. And his method of explaining every topic is really different than anybody else. And he had this shanku yantra and gnomon and sun shadow tools. All these things are all the time in his bag. So he's very passionate astronomer. And he uniquely blend the modern scientific practice and his deep interest in Indian astronomy that makes him a really compelling voice in both contemporary as well as traditional astronomical discourses.
I would like to work with him and do some measurements in Bangalore. He is about 6 kilometers from my place. I can go there and we'll conduct direct experiments, measurements, and report them here. But we need some time and at least a couple of weeks for that. I'm sure this will happen. Okay, we would like to do some measurement. Most of us are not aware of measurement, but because we are newly waking up to Indian astronomy. Actually, Indian astronomy existed ever since humanity was born, and everyone knows that. Only thing is we need to see how measurements have to be done. Most of us in India and in the rest of the world are lost in what is called as astrophysics, physics of the astral bodies, which is all right. There is no, there is no problem there. That can be there. But astronomy requires a different kind of a mindset, and I request Dr. Ram Mohan to cooperate with me, and we'll do some measurements and present it to this audience. Thank you very much.
I formally want to thank our speaker, Mr. Ram Mohan, who has integrated contemporary scientific practice with a strong foundation in Indian astronomy. And he offered a distinctive perspective across both modern and traditional frameworks. On behalf of NASNI, I want to thank Dr. Ram Mohanji for sparing time and giving such a elaborated talk here. And I hope and wish that we will make arrangement for another talk on a very such interesting topic by discussion. And I also thank all the members of NASNI who have spared time attended this talk. And thanks to Dr. Reshma for sparing time and introducing the speaker. Thanks to Dr. Aluwalia sir, who is with us and inspiring us all the time. And Ram sir, this talk is recorded and will be available on YouTube, and I will share the link with you also.
Thank you. Thank you so much.
In the end, I thank everybody, and especially our speaker. And we will meet in another talk next month on first Wednesday. Till then, thank you so much and good night.